This is a recap of the questions asked during Singapore JavaScript interview meetup on August 18th. The first question is, write your own version of for each. We all know how for each works. For each is a method on an array. So you can run for each on an array. For each is going to take a callback function. That callback function is going to execute on every element. So it executes on A, B, and C. What is the execution? You log it, so you print ABC. Ignore this undefined, it is just an editor thing. Now, for each does not return anything, well, it returns undefined. You need to write your own for each function that applies to every array object. So what you need to do is to write to array prototype, because array instances inherit from array prototype. If you change the array prototype, you make changes to all array instances. For example, let us say I change array prototype. I add a the, I call it the. Now let's print the before. And print it after. So before we print array1.the is undefined because it doesn't exist. Now we add this array prototype.the. This the is going to apply to every array instance. So now if you print the, it will print the. Same thing, ignore this undefined. Now your job is to, instead of writing an array.prototype.the, you need to write my for each. All right, so let's make it bigger. This is going to be a function that take a callback, and you need to write your stuff here. What you need to do is that after you write the for each function, you need to call it using the same syntax. If I run this function, it needs to have the same functionality as the native for each. So pause the video and think how you can solve it. Now, how shall we approach this question? First of all, how shall we access what is the array that called this callback? Because we use the function keyword, we can access using this keyword, right? So this keyword is who called me. But so if you print this, you print ABC, okay. Now, if you use arrow function, it's not gonna work because arrow function is lexically scoped, okay? So you need to use function. Okay, cool. Now, what does for each do? For each need to apply callback to every element. Well, something you can do is just loop through the array, just apply callback to every element. How do you access the element? Array I, right? Now, if you want to save some lines, you can just use this here, right? Put everything in one line, because why not? Oh, this.len. So it still works. Now, if you want to be strict, for each also taking an optional index and an array. So you can also pass in index and the array itself. It's the same thing. Okay, I know what you're thinking, what about sparse array, right? Because sparse array is going to have a different behavior. Now, what the native for each does is that it will ignore the sparse, we call it a holes, because those don't exist. It's called a sparse array. But if you use a for loop and just naively loop through, you will call those elements. That's why it is printing undefined. Again, I'm trying to keep it simple, so let's not worry about sparse arrays. But for all our intents and purposes, this line of code will do. Okay, so that's easy. Now let us move on to map. Write your own version of map. So if you're familiar with map, what map does is that it returns a copy of your original array. Your original array is not changed. So same thing, if you write array.prototype.myMap, it's gonna be a function that take a callback. Now we do something here. Now if I do console.log array1.myMap, from my callback will be this. This line of code is supposed to produce 2, 8, 18, and 32. All right. So pause the video and see if you can solve it. Okay, so how do you find this question? Something that is the same is access the array. So the array will be, okay, so this is the array. Now, same thing, in order to return a new array, we can create a new array, right? And in the end, just return this array. So just look through the array, use the callback. You use the callback on every array element, right? Now you are writing that result to the result. Looks like it works. Okay, so that is the warm-up. Let us kick up the game a notch. Write your own version of reduce. So what's up with reduce? Reduce take in one or two parameters. The first parameter is a function, a callback function. The second parameter is the initializer value. In this case, our initial value is 5. In this case, we don't have an initial value, so it will default to 0. So this is the two parameters that reduce will take. Now the first parameter, let's talk about the callback. What is this callback? The callback takes in two parameters. Let's not worry about the optional ones. So this is our callback. The callback is a function that takes in two elements and return a value. In our case, we're just gonna return the sum of the two values. Now, conceptually, what is accumulator and what is current value? Accumulator accumulates the callback's return values. So let's walk through this 1, 2, 3, 4. Initially, our accumulator, assuming we are talking about this function, we are starting off with 5. So your accumulator is 5. Our current value is 1, all right? So you return 6. Now in the next loop, our accumulator is 6 because you are accumulating it, right? So this is 6, current value is 2, so you return 8. So accumulator will be 8 when we come to 3. Current value is 3, so 11. Now at 4, you accumulated 11. Current value is 4, 15. That's why we print 15. Same thing, write your own reduce, my reduce. It will be a function that take a callback. It will take a init val, right? And do something. We can console log array 1.myReduce. Let us do reducer and 5. So this should give me 15. Let's also do a without initializer value. So pause the video and see if you can solve it. Okay, so how shall we approach this question? First of all, when we need to handle the case where we do not have an initial value. So let's just default to 0. If you provide, it will override the 0. Our reduce is going to return a result. So we can initialize to init val, or it doesn't matter, and return it, right? Same thing, let us loop through the array. I0 and less than, let me also do array is this, array.length plus I. So what shall we do here? We need to use callback. Now, what does callback take? Callback take two. Let us look at the callback. It taking two things. It taking an accumulator and it taking a current val. What is the accumulator? We can use the res as the accumulator. What is our current val? This is the current val, right? Now, what does it return? It returns the result. So you can just do res equals to this. Now, why does this work? Because we need to return the accumulation of everything, right? From start to finish. And callback returns the result of each accumulation. So once you finish every accumulation, just return it. Theoretically, you don't even need this result variable. You can even just use the same init val. Init val, init val, init val. Don't worry about it. It's the same thing. Now, of course, we can also do this, right? So this. So you remove one line. Then you can also remove this, right? So you put everything in one line because why not? Boom, it's the same thing. Okay, last question of the day. Implement flatten deep in Lodash. What does flatten deep do? Given an array that given a nested array, flatten it to a single array. So if you run this, it will be 1, 2, 3, 4, 5. Now you can also have arrays inside arrays, so 7, 7, 7. So you get 1, 2, 3, 7, 7, 7, 4, 5. So what you need to do is to give an array like this, write your own flatten instead of using Lodash. Try not to cheat by using the native flatten methods. Do your own function. And in the end, you should have the result of 1, 2, 3, 7, 7, 7, 4, and 5. Pause the video and see if you can solve it. By the way, there's no need for a callback, all right? First of all, let us access the array. So array is this. Now, what is the intuition here? How shall we approach this? Is it iteration or recursion? I hope you can see that this is a recursive problem, because how do you know how many loops there will be, right? Now you can count 1, 2, 3, 4, 5, but that's actually not true because there are two arrays inside this array. We do not know how many loops there will be. It is definitely recursion. Just think of every array inside array as an inception, as layers n level deep, right? So you are definitely using recursion. Okay, so when you're using recursion, let's just call it helper and call it. What should the helper take? The helper should take the array. Okay, cool. Now we can think of going inside each array as a different call stack. That means you are invoking the recursion whenever you see an array. If you only see a number, just push to the result array, right? So you can also have a result. It's a plain array. And in the end, we are returning the array. Whenever we see a number, we push the number onto the result array. Whenever we see an array, which will last, I don't know where it will go. I think it goes to here or here, I don't know. But whenever you see an array, you will invoke the recursive function go into the call stack. So I invoke the helper function whenever I see an array. Cool. So I will loop through each element. If it is an array, if my element is an array, I will invoke my helper function. I'll pass E. Else, my E is a number. Rest I'll push E, right? 1, 2, 3, 7, 7, 7, 4, 5.